Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to our NPTEL online certification courses on engineering drawing and computer graphics. I am Rajaram from Mechanical Engineering, IIT Kharagpur. Now we are covering lecture 3, Introduction to Engineering Drawing in module 1. The course basically contains engineering drawings, conic sections, orthographic projections, sections, isometric projections and overview of computer graphics and few design projects. The recommended textbook for our course is Engineering Drawing by N.D. Bhatt and others. Mainly we follow this textbook. In the last two lectures, we covered introduction, basic drawing instruments and lettering to be followed for any drawing. There we have learned an engineering or a technical drawing is a graphical representation of a part, assembly, system or structure, and it can be produced using freehand or mechanical tools or using computers. Once engineering or technical drawing is done, it will be sent it to production and that drawing will be called working drawings. In working drawings are the set of technical drawings used during the manufacturing phase of a product. They contain all the information needed to manufacture and assemble the product. And in our course, we mainly focus on engineering or technical drawing. In the last class, as a summary, we have tried to look at the different drawing sheets used A0, A1, A2 to A4 and their standard sizes. And also we have covered what kind of tables to be used for getting better drawing, and also the main accessories like mini drafter, compasses and dividers, pencils of various shades and their grades, the other accessories like set squares and protractor and other essential component eraser we try to look at. And then we covered what are the lettering to be used, what should be the height of a letter, thickness of a letter, if it is a lower case, if it is a upper case, what kind of dimensions one should follow, we try to look at. In today's lecture, we will cover what are the layouts to be used for a drawing sheet and dimensioning and tolerances to be used or mentioned in a drawing sheet. And we will mainly understand how to dimension a line, curve and other things, and how to address this tolerances issue. As I mentioned earlier, engineering drawing course has been used from past 100 years by variety of engineers and the technical content is vast. Though we are recommending one textbook, but this material has been taken from variety of sources. Whenever a source is there, we will acknowledge them thoroughly. If not, we will thankful to other online resources also. In this drawing sheet layout, standard layouts has to be used, and these standard layouts are basically specified by different organizations. In this, a standard is a set of specification of parts for materials or processes intended to achieve uniformity, efficiency and specific quality. So, these are the protocols which one has to follow. Examples for standard organizations are ISO, IC, SAE, ASTM, ASME, ANSI and BIS. ISO is international standards, SAE is Society of Automotive Engineers, ASME is American Mechanical Engineering Associations and BIS is Bureau of Indian Standards. Each of these organizations follows different kind of standard, but these days people are trying to look at for universalization of these standards, and mainly for our drawing sheets we go with Bureau of Indian Standards, that is this. Let us look at a template of a drawing sheet layout. So, here the thing what we are showing, trimmed edge is the paper up to which the cut has been done. The A0 sheet or A4 sheet which is available up to this length and width. Those edges are called trimmed edges. In the drawing sheet layout, we usually see title block, perhaps variety of drawings here within this space, some border information, some kind of letterings like A, B, C, D and some numbering like 1, 2, 3, 4. And one has to follow standard protocols to know about how much space has to be left between this title block and edges, and also what should be the border line width and what should be the length of that drawing. In this class, we will look at in detail for a drawing sheet layout. The first one for a drawing sheet layout are borders. Usually 10 mm or more space left all around in between the trimmed edges. So, the sheet is available up to that level and we are calling that one as the trim sheet, and from there usually we construct a rectangular block with minimum spacing as 10 mm or more. Anything more than 10 mm is always recommended. If we are saying 10 mm, 10 mm and 10 mm, minimum one has to use. Sometimes we can use 10 mm here, perhaps this will be 20 mm, that is also fine, but minimum of 10 mm has to be maintained. The next one is filling margin. If we are seeing from right side to left side, the width of these border lines are bit wider on the left hand side, these are wider. compared to this right side, and that space, extra space whatever we are going to use, minimum 20 mm space one has to leave, that is on the left hand side with border included. This is provided for taking perforation. If someone would like to staple these drawing sheets or perhaps make perforations, keep a record, this extra space will be used. The other one for a drawing sheet layout is called reference grid system. This is provided on all sizes of industrial drawing sheets for easy location of drawing within the frame. The length and width of the frames are divided into even number of divisions and labeled using numerals or capital letters. If we are looking at this on the drawing sheet, we can see a reference grid system. In the vertical direction, we give capital letters A, B, C, D starting with top left corner, and here also we see A, B, C and D. Similarly, in the horizontal direction, we see numerals 1, 2, 3 and 4. For example, we have a drawing of this here. There might be another drawing of the same either part or other things here. To better convey this message, we usually go with this reference grid system. The part will be in that reference grid system like 3, 4 and C and B information. So, this A, B, C, D 1, 2, 3, 4 represents the different areas, parts of the drawing sheet. For example, here W is in AB zone, in 1, 2 zone on the top right side, top left, top right, bottom left and bottom right. The grids along the horizontal edges are labeled in numerals, whereas grids along the vertical edges are labeled using capital letters or uppercase letters. The length of each grids can be between 25 mm and 75 mm. Depends on the drawing sheet, we use these lower limits or the upper limits. The other essential component of this drawing sheet layout is revision table. Here we can find that revision sheet. A revision table is normally located in the upper right of the drawing frame. All modifications to the drawing should be documented there. Usually for these engineering drawings, once component is made and if there is any revision required, one more drawing sheet will be provided with the revision. For that drawing sheet, usually the technical content or the information will be provided as a table. That is what we call revision table. For production drawings, the components involved in the drawing, for example, like one part is made with brass, other part is made with bronze, other part is made with iron. So, these different materials has to be mentioned. So, for the purpose, material or parts list, which is called bill of materials, are also included. If the drawing contains a number of parts, or if it is an assembly drawing, a tabulated part list is added to the drawing. The bill of materials is usually placed at the bottom right of the drawing frame, just above the title block. Usually we have title block here, above that we have this. Let us look at an example of a drawing sheet. So, the drawing sheet with lettering, the reference grid systems, which we can see it. These are the reference grid system. We can see the title block and the basic components we can see, the isometric views, the 3-dimensional objects, and their projectional views we can see it. If any inner details and so on to be shown, that will also be shown. We can see that capital letters have been used for the title block, and here we can see some kind of numbering kind of system. There are lines and some numbers. These are called dimensions, and we will see it later. Now, coming back to the dimensions of the drawing sheet, where we have shown the pictures, for example, something like a circle with diameter and so on, so things. How to name such kind of things we are going to look at in this section. In this, we look at what are the dimensions involved, fundamental rules of dimensioning, guidelines required for good dimensioning in engineering drawings. Let us look at the first part, what are dimensions. We use dimension to represent size and position of the design or model shape. A dimension is a numerical value expressed in appropriate units of measurement and used to define the size, location, orientation, form or other geometric characteristics of a part. For example, I want to represent this rectangle. Then naturally, I have to mention what might be height and what might be its width and length. Perhaps it might be 5 meters above the ground level. So, this kind of dimensioning which we are going to learn it in this lecture. A method of communication to machinists in the production facility requires proper dimensioning. This dimensioning of these drawing sheets or the technical information is of different kinds. They can be linear dimensions, it can be angular, perhaps representing radius or diameter of a cylinder or part of a curve, and with respect to certain reference scale. Let us look at basic terminology of dimensions. Here we are showing an object of particular shape. There we are showing something like lines, an arrow and some numerals with certain decimals. Similarly, here also we are showing some numerals with arrows. Those are called dimension. Precisely, these are the large scale information. So, we call that as basic dimension value. There are small information also, this is also part of the dimension. So, this is dimension, this is also dimension, dimensional value, and this length is the dimension. To represent dimension, we require a dimension line. So, there is a line. When dimension is ending, we show it by arrow. So, a line with an arrow is called termination symbol. Any length scale which we would like to use, we have to show it by line with arrows terminating heads. When we are showing dimensions, occasionally we draw lines. For example, here this one and this one. These are not part of the drawing, but to represent this dimension line, we usually draw what is called extension line. Whenever curves are involved, it is a common practice to show the radius of that dimension. For example, here we have a semicircular arc. So, it must be having a radius of 1.25. And for radius symbol, we use letter R. Here we are showing leader line, this is also a radial line. So, we can see there is a arrowhead going in that direction, phi represents diameter symbol and 1.0 is that dimension value. So, whenever diameter symbol has to be used, usually we go with phi, Greek letter, and whenever it is radius, we go with capital R. There is one more line called center line. Whenever we have cylindrical objects and we would like to show about that axis, we go with these center lines. Whenever we would like to represent reference dimensions, we use that parenthesis and 2.50. It indicates that this length supposed to be 2.5. Maybe in the drawing it might not be 2.5, but whenever people would like to simplify these dimensions, just to represent, they use these parentheses with the letter 2.5 and arrow heads. That kind of dimensions are called reference dimensions. These are the extra dimensions given just to represent the drawing. This dimension must have been already given in the drawing as intricate detail. Let us look at other drawing. Here we are seeing this shape. We can note here there are extension lines with 1.20 as the basic dimension. Here also we can see that there are center lines. Whenever we have cylindrical objects, for example, this is the cylinder, cylindrical portions, and would like to represent something like an axis, we use that center lines. Whenever material has been scooped out, to show that, or whenever there is a material is about to begin, we show it by these dash lines. These are the inside details. During our course, we will learn about what are these dash lines and also dash dot lines and what are these continuous lines also. As of now, we will look at it dimensions and radius symbols, diameters and these reference dimensions. Whenever there are not to scale dimensions, usually we represent it by that arrow, a line indicating 0.75, whatever the dimension is involved in that, we show that dimension, and whenever not to scale, we just leave a underline. So, the distance between these 2 points is 0.75 in this case. Thank you very much.